Betelgeuse, a celestial object that has fascinated astronomers and enthusiasts alike, presents a captivating mystery in modern astrophysics. Its designation as a red supergiant situates it at a crucial stage in stellar development, a phase that signals the end of a massive star's life cycle. This stage is marked by significant changes in the star's physical properties and its ultimate fate, which could profoundly enhance our understanding of stellar processes and cosmic phenomena. The developmental path of a red supergiant like Betelgeuse involves substantial changes. Such stars have advanced from earlier stages of stellar life, progressing through the main sequence and giant phases. These stages are characterized by the star's core fusing hydrogen into helium. As this fuel depletes, the core contracts while the outer layers expand. For Betelgeuse, this results in an enormous, swollen outer envelope and a core that becomes increasingly unstable. The core of a red supergiant like Betelgeuse eventually becomes so dense that it begins to fuse heavier elements, such as carbon and oxygen. This fusion process generates tremendous energy, causing the star's outer layers to expand even further. However, this phase is relatively brief on cosmic timescales. As the star continues to burn through its nuclear fuel, it reaches a critical point where it can no longer support the weight of its outer layers. This leads to the core's collapse, resulting in a supernova explosion. The conditions leading up to a supernova are incredibly complex. For Betelgeuse, the variability in its brightness and the recent extreme dimming are key indicators of the processes occurring in its outer layers. Changes in luminosity can be associated with alterations in the star's outer envelope or interactions with its surrounding environment. Such fluctuations might also indicate that the star is undergoing internal reconfiguration in preparation for eventual collapse. Moreover, studying Betelgeuse provides a rare opportunity to observe a star on the verge of a supernova. By analyzing its light curves and spectral data, scientists can gain insights into the mechanisms driving its instability. The James Webb Space Telescope, with its advanced observational capabilities, is particularly well equipped for this task. It offers unprecedented resolution and sensitivity in observing the infrared spectrum, allowing researchers to peer through the star's dense outer layers and study its internal dynamics. Another important aspect of studying Betelgeuse involves understanding the broader implications of its impending supernova. When a massive star like Betelgeuse explodes, it releases a tremendous amount of energy and material into space. This explosion disperses heavy elements synthesized in the star's core, enriching the interstellar medium with elements essential for the formation of new stars and planetary systems. These supernovae also produce neutron stars or black holes, depending on the mass of the remaining core. The impact of a supernova on its surrounding environment is considerable. The shockwaves from the explosion can trigger the formation of new stars by compressing nearby gas and dust. This process, known as supernova-induced star formation, can lead to the creation of a new generation of stars and planetary systems. Additionally, the energy released can affect the dynamics of the galaxy, influencing the distribution of matter and the evolution of galactic structures. From an observational perspective, the imminent explosion of Betelgeuse offers a rare chance to witness a supernova event in real time. Historically, the study of supernovae has been limited to observations of past events. For example, the supernova SN 1987A in the Large Magellanic Cloud provided valuable insights into the nature of supernovae and their aftermath. However, observing Betelgeuse's transition from a red supergiant to a supernova would allow scientists to study the events, precursors, and dynamics up close. Beyond the scientific significance, the potential supernova of Betelgeuse also holds a certain degree of public fascination. The star's brilliance and its dramatic end are compelling topics for both amateur and professional astronomers. Educational programs and media coverage of Betelgeuse's evolution serve to inspire interest in astronomy and space science among the general public. As a result, Betelgeuse has become a symbol of the dramatic and often violent processes that govern the life cycles of massive stars. As researchers continue to monitor Betelgeuse, they are using various observational techniques to complement data from the James Webb Space Telescope. Ground-based observatories such as the Very Large Telescope, VLT, and the Gran Telescopio Canarias, GTC, provide additional data that help refine models of the star's behavior. These observations are essential for constructing a comprehensive picture of Betelgeuse's current state and its imminent future. The study of Betelgeuse and similar stars also contributes to our understanding of the broader universe. By analyzing the life cycles of massive stars, scientists can gain insights into the formation and evolution of galaxies. The processes governing stellar evolution are intricately linked to the dynamics of galaxies, influencing everything from star formation rates to the distribution of elements throughout the universe. Furthermore, research into stars like Betelgeuse helps refine our models of stellar nucleosynthesis, the process by which elements are formed within stars. This knowledge is crucial for understanding the origin of elements in the universe and their distribution across different cosmic environments. It also informs our understanding of the conditions that led to the formation of our solar system and the elements that constitute the Earth. In summary, Betelgeuse is more than just a captivating star, it is a pivotal subject of study in astrophysics. Its potential to become a supernova offers a unique opportunity to explore the final stages of stellar evolution and the impacts of such explosive events on the universe. As researchers continue to investigate Betelgeuse, they contribute to our broader understanding of cosmic processes and the dynamic nature of the universe. The insights gained from studying Betelgeuse will undoubtedly enhance our knowledge of the cosmos and continue to inspire both scientists and the public alike. Anticipating that lines might be removed. The most fascinating star I can think of is one that could be astonishing in our sky, Betelgeuse. This formidable entity exists as a red supergiant star. If placed where the Sun is, it would extend to the orbit of Jupiter. It is colossal, highly unstable, and on the brink of exploding. The universe doesn't function solely through dramatic events like the most feared cosmic bursts, which could profoundly alter all that we observe and don't yet comprehend. Nevertheless, Betelgeuse is recognized as an exceptionally massive red star that is, in many respects, larger than our Sun. Brian Cox and other astrophysicists suggest it could go supernova at any moment. People are generally anxious about what might happen, especially since the James Webb Space Telescope is capturing stunning images of the star. This heightened interest in Betelgeuse is not only due to its potential to become a nearby supernova within a human timescale, but also because of the wealth of scientific data it can offer. Unlike distant supernovae that appear as brief flashes of light in faraway galaxies, Betelgeuse resides relatively close, approximately 642 light-years from Earth, making it one of the best candidates for in-depth, long-term observation of a massive star in its final evolutionary phase. The brightness fluctuations observed in Betelgeuse over the past few years have sparked significant speculation. In late 2019 and early 2020, the star dimmed so dramatically that many wondered whether a supernova was imminent. Scientists later determined that the dimming was likely due to a massive ejection of material from the star, which formed a dust cloud that temporarily blocked some of its light. This event, sometimes referred to as the Great Dimming, served as a powerful reminder of how dynamic and volatile the final stages of a massive star's life can be. Ongoing observations continue to track such phenomena, providing valuable insights into mass loss, surface convection, and internal stellar dynamics. These insights not only inform stellar physics but also help astrophysicists refine models of how red supergiants evolve and die. Furthermore, the ability to correlate surface activity with deeper core processes, through tools such as spectroscopy, photometry, and infrared imaging, allows scientists to probe beneath the surface of these enigmatic giants. If Betelgeuse does go supernova in our lifetime, it will be a spectacle unlike anything modern humanity has witnessed. The explosion would likely be visible in broad daylight for weeks, potentially casting shadows at night. While this might sound alarming, experts assure us that Earth is not in danger. The supernova's energy, although immense, would not pose a direct threat due to Betelgeuse's safe distance from our solar system. Still, the cultural and scientific impact would be tremendous. A supernova in our night sky would capture global attention, drawing millions to look upward and contemplate the forces that shape our universe. It would be a unique opportunity for international scientific collaboration, education, and public engagement in the field of astronomy. Looking further into the future, the remnants of Betelgeuse, whether a neutron star or black hole, would continue to provide data for decades or even centuries. Observing how the surrounding interstellar medium responds to the shockwave, studying the expanding supernova remnant, and mapping how newly formed elements disperse would yield a clearer picture of the life cycle of stars and the chemical evolution of galaxies. Betelgeuse, in essence, stands as both a cosmic time bomb and a living laboratory. Its potential transformation into a supernova encapsulates the life and death of the universe's most powerful entities. As we continue to watch and wait, we do so with a mix of awe, curiosity, and reverence for the forces that shape the stars, and, ultimately, ourselves. An Orion star, Betelgeuse has a brightness so great that even ancient civilizations observed it. The forthcoming star Betelgeuse can be found on the eastern shoulder of the constellation Orion. Its name comes from the fact that Betelgeuse is the second largest star in the constellation. Its massive size makes it one of the brightest stars in the night sky. In addition to its brightness, the star has a curious shade of red that is quite significant, as we will see. Betelgeuse has been widely known to us for some time. It was also studied by Tao, a Greek astronomer. At the time, people primarily understood stars based on their color. Tao noted that Betelgeuse was orange. Recently, astronomers have been examining the star more closely and now have a clearer understanding of its characteristics. One notable feature is that the star's brightness fluctuates significantly, with a variability of 0.6. Betelgeuse is a variable star, meaning its brightness changes over time. However, in 2019, astronomers noticed unusual behavior. Betelgeuse did not stop shining completely, but it became noticeably fainter, dimming to a magnitude of approximately 1.6. Astronomers quickly began investigating the cause of this change in what had been the 10th brightest star in the sky. Based on their analysis, which highlighted these unexpected signs, they issued a cautionary statement regarding the star's strange behavior. Betelgeuse may soon go supernova, according to scientists. Brian Cox, a well-known scientist who taught particle physics at the University of Manchester, made this alarming prediction, and is not exaggerating. Cox also hosts a science show, writes popular science books, and promotes public engagement at the Royal Society. His description of Betelgeuse as a time bomb that could detonate at any moment is especially concerning, particularly since the James Webb Space Telescope has provided substantial evidence to support this claim. What are these unusual signs? What has caused such alarm in the field of astrophysics? Betelgeuse has been classified as a supernova candidate, yet researchers remain uncertain about the exact timing of its explosion. One reason for this classification is its mass, many times that of the Sun. To be considered a supernova candidate, a star must be several times more massive than the Sun. Betelgeuse has been studied using a variety of instruments, including the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, to better understand what is occurring in the space around it. This adds another layer of intrigue, as their findings remain fascinating. While our Sun was born approximately 4.6 billion years ago, Betelgeuse likely began emitting strange signals much more recently, hinting at its uncertain future. What exactly have scientists found? They've detected unusual light waves coming from or toward Betelgeuse, highly peculiar. But that's not all. Betelgeuse's fluctuating brightness and dark spots, similar to sunspots, were observed, but the rate of these changes has raised questions. The star appears to shift too quickly, making it a subject of considerable interest. Could these signs indicate that the star is about to explode? Analyzing how stars evolve is essential to understanding the universe and its many stages of stellar development. And one conclusion becomes increasingly plausible: the star is spiraling out of control. Recent data from the James Webb Space Telescope reveals that Betelgeuse's brightness is changing daily. While scientists are fully aware of the variability in such stars, they find this level of fluctuation unusual, potentially indicating that the star is reaching a point of no return. To explain this, one theory has been proposed. The European Southern Observatory reports that Betelgeuse is emitting a large amount of unusual light. Its apparent imminent demise is the primary cause of concern. While it won't explode tomorrow, scientists believe its days are numbered. As stars approach the end of their life cycle, they go through various phases of transformation. For Betelgeuse, that end is near. When the explosion does occur, it will be a remarkable spectacle. Unexpected data from the James Webb Space Telescope suggest that Betelgeuse is approaching the point of no return. According to Webb's research, the star could potentially brighten so much that it will be visible in broad daylight. It is essential to stay informed about its developments, even though the exact timeframe remains unknown. Betelgeuse serves as a reminder of the universe's dynamic and unpredictable nature as it nears this crucial turning point. Despite the star's enormous size and energy, the good news is that Earth is not in danger. Betelgeuse is located approximately 640 light-years away from our planet, far enough that even a powerful supernova explosion would not cause harm. However, the visual spectacle would be unlike anything seen in recorded human history. If Betelgeuse were to explode, it could shine as brightly as the full moon, possibly even brighter, and remain visible during the daytime for several weeks or even months. The night sky would be dramatically transformed, with Orion's shoulder glowing in a persistent light that would captivate astronomers and casual skywatchers alike. But beyond the visual impact, the event would offer an unprecedented scientific opportunity. Supernovae are among the most energetic and transformative processes in the universe. They play a key role in spreading heavy elements, like iron, gold, and uranium, throughout space, contributing to the creation of planets and even life itself. Observing a nearby supernova in real time would provide valuable insights into stellar evolution, nuclear fusion, and cosmic particle acceleration. Scientists are already preparing for this eventuality. Observatories around the world, from Chile's Atacama Desert to Hawaii's Mauna Kea, have monitoring systems in place. Instruments like the Vera C. Rubin Observatory and the upcoming Nancy Grace Roman Space Telescope are expected to contribute to this effort. Additionally, neutrino detectors, such as Japan's Superkamiokande, will be watching closely, as a supernova is expected to produce an enormous burst of these ghostly particles that could be detected even before the visible explosion reaches Earth. The countdown is unknowable. It could happen in a year, a century, or tens of thousands of years from now. Astronomers often remind the public that soon in cosmic terms may not align with human expectations. Still, the increased activity and irregular patterns observed in Betelgeuse suggest that the star is firmly in the final stages of its life. So, what can we take away from Betelgeuse's approaching fate? It reminds us of the fragility and wonder of existence, that even giants in the cosmos have lifespans, that the heavens above us are not static, but alive and evolving. As Betelgeuse inches toward its final act, we are offered front-row seats to a cosmic drama that may unfold within our lifetime, a rare gift from the universe to humanity. Until that moment arrives, we watch, we study, and we wait.